Give me like 2 minutes.
We're doing 13 or are we doing 11?
Yeah, we're doing 13 together. Okay, so I'll give you 1 minute head start. You're welcome. Tyson. I remember how to eat yesterday, but I don't remember today. Okay, so let's talk about when do we use implicit derivative. That's probably the most fundamental question that you're gonna have. When to use implicit derivative is when you see that this equation, and then you have a mixed term. For example, x squared y cubed, or y to the cube. You not get y by itself. It's not y equal to something. So it's y equal to something is always explicit. You can take a derivative explicitly. Now, this is another case when you have, so one other case that you might have is if the y is within the argument of a function. So within, let's say sin y equal to x. That's like perfect example. You had to use implicit derivative. So in this case, the y, see the y squared kind of tells you that you had to do implicit. And also there's a y here that's within the natural log. That's also told you that this need to be implicit differentiations. Remember, anytime you don't have y equal to something or f of x equal to something, more likely, if they ask you to take a derivative, more likely they'll be implicit. Because this can be done explicitly. You just have to take a derivative right side, you take a derivative right side, you're done. You don't have to do any more work. So your 1 minute's up. Okay? So what we're going to do is show you how to take a derivative of this. Now derivative of this, so I'm going to d to the dx on both sides, which is derivative with respect to x. So derivative with respect to x is going to give you 2x. And then, Joanne, you're not here before. Technically, there was something happen afterwards. It's a chain rule. You take a derivative of 2, so 2 placed in the front, 2x, right? And there was a derivative of x respect to x. So technically, there is something that usually never written. It's actually dx over dx. But dx over dx is not just 1, so that doesn't make any difference. Now, if you have other variable than x, then this part will be different. So now, what we're going to do is minus 3. Now, we're going to have, like before, is derivative of y, natural log of y is y prime over y, right? I'm going to write down in terms of y prime over y. Why is y prime over y? Because if you do derivative other than x, then there's a y prime over y, because there's u and u prime over u. Now I'm going to take a derivative of this, 2y squared. Now Joanne, you're probably not here last time, because you have y squared, you're going to take a derivative of that. It's going to give you 2y. But in this case, there was a dy dx. There's a dy dx. So for me, I can write this term in dy dx if you wanted to. That's fine. This is dy dx, which is this part is also dy dx to maybe show you a little bit better. So anytime you take a derivative to the y respect to x, you're going to get some type of dy dx and multiplication at the end. Does that make sense? Now derivative of 10 is going to give you a 0. So that's a 0. Now what you're going to do is all the dy dx term, you want to isolate them. So you didn't move any other term that has no dy dx to the right side. So it'll be minus 3, and this dy dx here over y plus 2y dy dx is equal to negative 2x. Are we okay here? Can I factor out dy dx? So it'll be negative 3 over y plus 2y is equal to negative 2x. Let's remember that first day I met you, I give you a pig problem, I asked you to solve it. Yeah. And that's why you had to factor that dy dx out. And after dy dx, factor out, you can divide it to the other side. So it'll be negative 2x over negative 3 over y plus 2y. Now, here's algebra things that you guys need to remember. This is called a complex fraction, which is a fraction within the fraction. You got negative 3 over y within this whole fraction. Therefore, it's not the most simplified answer. So what you're going to do is look at the denominator of the complex fraction. The denominator of complex fraction is y. Now, what's powerful things in math is you can multiply top and bottom by y, which is you're not changing this fraction. Why? Y over y is 1. Am I changing this fraction? No, I just change it the way it looks. So on the top, it's going to be negative 2xy. On the bottom, if you multiply by y, distribute to the bottom, that y and that 1 over y will cancel out. So it'll be negative 3 plus 2y squared. And there you go. That's a final answer for dy dx. You got it? Okay. So your homework gonna have one question of implicit derivative. Make sure you do it right. Make sure you understand it. Make sure you got it.
One question?
I can give you 2.
Okay.
You want a 10? I can give you 10.
No, I'm just.
Which time around today? Yeah.
No, it's just something like this. It's fair.
It's just one.
So like, you're just gonna do like just the final page?
Yeah. That's what I said.
Oh, there's more than one question?
Yeah.
Yeah, it's got a lot of homework last night.
But I'm confused.
But the first part is a pre-calculus, and the second part, the page 3 is the calculus part. Yes.
The first part?
Next Tuesday. Okay.
Rob's ass.
So what we're gonna do is we're gonna name a questions. Okay. What we're gonna do is name a question. This question is like this. So implicit, hopefully nobody has a major problem. If you do, then practice today's homework. We'll go over tomorrow. Now we're gonna talk about what's today's difference between yesterday's difference. Yesterday we talked about this question: y equal to x squared times 1 minus x squared to the x minus 5 to the 4th power. I don't know what is it, but I don't remember what exact. Great question. But we did something like this. Do we do quotient rule? We did not. Yes, thank you. Derek, we did not do the quotient rule. That's awesome. So it's going to be y equal to, this one, you're just going to be using logarithm property. If you use logarithm property, everything's going to be easy. So it'll be 2 natural log of x plus 1/2 natural log, 1/2 natural log of 1 minus x squared plus minus 4 natural log of x minus 5. Is that okay? Yeah. Now I'm going to take a derivative. So this one is going to be dy dx. That's equal to 2 over x plus 1/2 times negative 2x over 1 minus x squared minus 4 times 1 over x minus 5. And you're like, yes, I got this. The answer is equal to 2 over x. The 2 cancel out. So it'll be minus x over 1 minus x squared minus 4 over x minus 5 dy dx. Today's question is just add one more step. And the major difference between those two questions is this. Today's question is going to look like this. Exactly the same thing, but just without a natural log. Now, I promise you, a lot of people is going to do quotient rule, but you don't need to do quotient rule. Just give me 2 minutes. So what you're going to do is going to do natural log of both sides. You see natural log of both sides? And then when you take a derivative of this one, you're going to get y prime over y. Does that make sense? And then the derivative of this side, we already know. The derivative of this side is 2 over x minus x over 1 minus x squared minus 4 over x minus 5. Now, all I do is just move the y, multiply y on both sides. So multiply by y on both sides, but we do know what is y. Y is the blue part. which is x squared square root 1 minus x squared over x minus 5 to the fourth power times 2 over x minus x over 1 minus x squared minus 4 over x minus 5. And that's it. That's the final answer. The only thing extra today is there's y in the front. But there is no natural log to start with. So if you have no natural log to start with, you have to natural log to both sides. If you natural log both sides, on left side, it's going to give you y prime over y. And that's the situation that you're going to have. Hi, June.
Is question a little harder than this?
No, it's not harder than this. It's actually the same level of difficulty, except just writing extra y on left and right side. But because the question starts without natural log, so you have to natural log both sides before you do that.
We're going to
We're gonna go to the bathroom. And
You're going to go bathroom together to pee? Dartmouth? Nice. Well, he had to have a test score too to get there, though.
Yeah, Nico, he's very smart.
Oh, he's pretty smart. Yeah, you have to have like 1400 on SAT to go to Dartmouth, even your athlete.
Oh, yeah.
Really? It's not you.
No, I know, but the Nico, how did Nico have 4?
They're not. Maybe they considered more of his reading score instead of.
No, because Dartmouth, I have a golf player one there. She had to score 1400, and she was a really good golfer.
Because of baseball. Some they like for athletics. Sometimes they make like little
He was the leader.
exceptions related stuff.
Looks good.
Leader.
They find a way to get you in.
If it didn't really like you, right?
For the test corrections, do we just write it on the same?
Yeah, you had to find out how to do the right thing.
Okay, but on this paper?
No, on separate sheet paper with staple with it.
I have a science Olympiad meeting.
You have what?
A science Olympiad meeting.
For what?
Wait, don't you have science Olympiad too?
What?
I thought you have science Olympiad too.
I do, but not for her event. I didn't know you were in Science Olympiad.
You literally saw me at the event.
I did?
Both of them.
Yes, I did! Oh my gosh, that's so
Wow.
Zach is like,
I forget everyone. I'm so sorry.
do you understand stuff today, Daniela?
Yeah.